Okay. I guess I'll get started. Uh, okay. Yeah. Um, so welcome guys. There's not many people here today, but um today is Intro to Science Day 3, and today you guys will be learning about chemistry. So, what exactly is chemistry? Chemistry is a fancy word that describes the study of matter, and matter is basically everything around us. So that can be like your phone, it can be your computer, it can be your walls, literally everything. So chemistry is like detective work that helps us understand how things are made and how they can change. So imagine that you have a toy made of plastic. So chemistry is basically it helps us learn what plastic is made of, how it is made, and how it can make different things like cars, dolls, action figures, and a much more. So chemistry also helps us understand how things can change. For example, have you ever seen rust on an old bike, or maybe rust on like a giant like block of steel or something? So that's a change that happens to metal over time. And chemistry helps us figure out why it happens and how we can prevent it. So in simple words, chemistry is all about exploring the stuff around us and figuring out what it is made of and how it can change. It's like being a scientific detective. So I'll introduce you to the states of matter. And as I said before, matter is what is all around us. The three main states of matter are solid, liquid, and gas. So solid is right here, liquid here, and gas is just kind of invisible most of the time. Solids are, um, well, imagine this. So imagine holding a piece of chocolate or an ice cube. So solids basically have a shape and you can easily touch it, right? They're firm and solid and well, solid, and they don't flow like liquid. So rocks, toys, even your desk, those are examples of solids. Now we have liquids, which well, think about pouring yourself a glass of water or swimming in a pool. So yeah, liquids are basically a form of matter that flows around. They don't really have a fixed shape. They kind of can just adjust to whatever their surroundings are. So if you put like an object in a pool, water will go around it, right? So examples of liquids include water, juice, and milk. And then gases. So whenever you blow a balloon or feel a breeze in the air, that's basically gas. They're all around us, even though we can't usually see them. And they're spread out and fill any space they have. So examples of gases are the air that we breathe in and out, the gas in a balloon, and even steam that's coming from a hot shower. Sometimes matter can change from one state to another. For example, if you heat up ice, it melts and turns into water. This is called melting. And if you heat up water even more, it can turn into steam, which is a gas, and this is called evaporation. Okay, so next we have elements and atoms. Elements are the building blocks of everything around us. They're like special ingredients that make up all the different things we see and touch. Um, so atoms typically look like this over here. One second. Okay, sorry about that. But yeah, atoms are basically the tiniest particles of an element. And so they're really small, and they're so small that we can't see them with our naked eyes. Atoms are basically, think about it this way, atoms are like the letters of an alphabet, and you know how letters of an alphabet combine to make words, atoms combine to make uh, different elements, different compounds, a bunch of different stuff. So each element has its own kind of atoms, except having a special recipe for each atom. Excuse me. For example, oxygen is an element, and its atoms are always oxygen atoms. Same thing can go for other elements like hydrogen, carbon, and gold. Their atoms are always hydrogen atoms, carbon atoms, and gold atoms. Elements can join together to make new things. It's like how different letters combine to make words, and how words combine to make sentences or phrases. So when hydrogen and oxygen atoms come together, they form a new substance called water. That is one example of compound elements. Scientists have discovered many elements, and they are organized in a special chart called a periodic table. And I will show you guys that the periodic table in the next slide. Each element has its own symbol, and I'll show you guys in the next slide. All right, so the periodic table, here it is. So all of these symbols right here, all of these squares represents one element, okay? So you guys don't have to really worry about how this is ordered and how this works. Just this is kind of an introduction, but so right here, this is hydrogen, helium, lithium, I think that's beryllium, and then boron, carbon, nitrogen, oxygen, fluorine. There's a bunch of different elements. So yeah, so this is just basically a chart that helps organize all the different elements. Let's see what else. So yeah, they're organized in columns and rows, right? So the rows right here, so these little, like from here to here, they're called periods. And these columns here, right, they're called groups or families. And so basically elements in the same group or family, they have similar properties, right? So yeah, like a real member, real family, they share certain traits. What else? It also helps us learn the periodic table, that is, helps us learn more about each element, right? So we can find out its name, so the symbol, and other important information. It's like having a special guidebook for all the elements. And so these right here, the numbers, they represent how many protons, right? So protons they form the nucleus. You don't have to worry about it too much right now, but you can just kind of, if you are given the number of protons, right, you can kind of find out which element it is. So if somebody says 25 protons, you can find out it's this element over here, or maybe 14 silicon over there. So and the table keeps changing, so people add more elements to the day, right? So these elements are the most recent elements discovered. So yeah, and now I'll talk a little bit about chemical reactions. So if you've ever seen like changes happen before your eyes, right, it's basically usually a chemical reaction, and so it's kind of like magic happening in the world of atoms and molecules. So a chemical reaction occurs when substances or substances and elements, come together, and they will change it to something new. It's like mixing ingredients to create a delicious cake, cookies, or maybe just watching a color changing experiment, like when you pour food coloring into water. So that's an example of a chemical reaction. Another very famous type of chemical reaction is when you mix in vinegar and baking soda, and that will usually fizz and create bubbles. And they'll also create a new substance as a byproduct called carbon dioxide gas. Another type of chemical reaction, burning, rusting. So those are different types of chemical reactions too. The metal for rust is reacting with oxygen in the air, and that creates a new substance called rust. Chemical reactions can also produce heat or light, which is very common. So whenever you like light a matchstick, that will create heat. And then new substances are being formed because of the rubbing. Whenever you rub something against a matchstick, right, that friction will create heat and light, or fire. And yeah, they happen all around us. Fireworks are a very, very popular example. And I'll get into the real world examples right now. So chemistry, it's not just a subject, right? So we can I'll talk to you about some applications of chemistry or examples. So number one, cooking. Chemistry plays a huge role in cooking and baking. So whenever you mix ingredients, when you change textures, create delicious flavors, right? So those are all a part of chemical reactions that are happening in the kitchen. Colors and dyes. So have you ever wondered how clothes, paints, markers, whatnot, get their different colors? So chemistry will help create and study different colors and dyes that make our world more colorful. So slime and goo. So slime making is very it's a popular little activity that involves chemistry, right? So you're mixing ingredients, so special glue and special liquid like borax. And when you mix them together, they'll create a weird squishy substance that is really fun to play with. Cleaning products. So if you ever noticed how different cleaning products can remove stains or make things sparkle. So yeah, they were developed using chemistry, and chemistry uses products that work by breaking down dirt and grime. Um, Medicine and healthcare. So chemistry is very prevalent in healthcare. Whenever you're developing medicines that are usually made to help us feel better and healthy. Scientists use chemical reactions to create and test new drugs. And finally, fireworks. So fireworks are a fantastic display of colorful lights in the sky. The vibrant colors and sparkles are created through specific chemical reactions that are happening inside of the fireworks. So with that being said, here are some fun facts. So carbon is one of the most common elements in the universe. So it's found in pencils and diamonds, and it can form well over 10 million different compounds. And that's crazy, honestly. So whenever you see anything, most likely it has carbon in it. The first fizzy soda was invented by a pharmacist named John Pemberton, and he created the Coca-Cola in 1886. And I believe he was trying to create a medicine that would help for headaches. I'm not sure, you might have to get that fact checked. But yeah. And then if you can notice, let's go back to the periodic table. Some of these elements, especially the newer ones, they have some weird names, right? So for example, Einsteinium was named after Albert Einstein. Livermorium was named after the local Lawrence Livermore National Laboratory, and that's just over in Livermore. So it's really cool. And I think one more. I think Mendelium was named after another scientist as well. So yeah, and as I stated before in the last slide, many of the colors that we see in fireworks come from different chemical elements. So strontium makes red and barium makes green. Okay, so that's it for today. It was a pretty short webinar. But I hope you guys can come back tomorrow for our final webinar in our Intro to Science series. Have a great day. And if you have any questions, just feel free to stick around and let me know. Thank you, guys.